In this video I want to talk about the stoichiometric calculation. So let's see first of all how to calculate the amounts of reactants and products. So if you know the number of moles of one substance, the balance equation tells you the number of all others in the reaction. So it means that if you know the number of moles of one substance, then you can calculate the amount of all other reactants or products. So in a balance equation, the number of moles of one substance is stoichiometrically equivalent to the number of moles of any other substance. Let's have this example. Here we have mole to mole ratios. So we have 2 octane plus 25 oxygen gives us 16 CO2 plus 18 water. So it means that 2 octane molecules can react with 25 oxygen molecules, and they produce 16 carbon dioxide molecules plus 18 molecules of water. Or we can say 2 moles of octane plus 25 moles of oxygen results in 16 moles of carbon dioxide plus 18 moles of water molecules. So when 2 molecules of liquid octane react with 25 molecules of oxygen gas, 16 molecules of carbon dioxide gas and 18 molecules of water vapor are produced. So we have it here. So it's called mole to mole ratios. So we're talking about the molecules. So 2 molecules of octane is stoichiometrically equivalent to 25 molecules of oxygen. Or we can say 2 molecules of octane is stoichiometrically equivalent to 16 molecules of CO2 based on this balanced equation. 2 molecules of octane is stoichiometrically equivalent to 18 molecules of water. Or we can do the same thing for any other substances in this chemical reaction. We can say 25 molecules of oxygen is stoichiometrically equivalent to 16 CO2 or 18 molecules of water. Or we can say 16 molecules of CO2 is equivalent to 18 molecules of water. So now we can replace molecules by number of moles. If I go back here, if we know the number of molecules based on Avogadro number, we can convert it to moles. So we have the same ratio. So we can say 2 moles of octane is going to be equivalent to 25 moles of oxygen. And exactly the same thing. So we just replaced all molecules with moles. So that's called mole to mole ratio. Let's have an example. How many moles of sodium phosphate can be made from 0.24 moles of sodium hydroxide by the following unbalanced equation? So here we have sodium hydroxide plus phosphoric acid. So it's going to give us sodium phosphate plus water. First of all, we need to balance it. So if we balance it, we can say here we have 3 sodium. We put 3 here. P and P is equal, so it's already balanced. And here we have hydrogen, 3 here plus 3 here, 6, and here we must have 3. So if I go here, we have 3 NaOH plus H3PO4 is going to give us Na3PO4 plus 3 waters. So we can say 3 moles of sodium hydroxide is stoichiometrically equivalent to 1 mole of sodium phosphate. So here we said how many moles of sodium phosphate can made from 0.24 moles of sodium hydroxide. Okay, so it means that if we have 1 mole of sodium hydroxide, if we have 3 moles of sodium hydroxide, we will produce 1 mole of sodium phosphate. Now, since we have 0.24, we need to calculate how much Na3PO4 we can produce. So we do this equation here, 0.24 mole NaOH, that's the actual amount. And here is the mole to mole ratio. 1 mole of Na3PO4 is stoichiometric equivalent to 3 moles of sodium hydroxide. So if we do the calculation, we get 0.0800 mole sodium phosphate. So if we want to do the mass to mass calculation, first of all, for any substance we have the mass, we divide it by the molecular weight of substance A, and then we calculate the number of moles of that particular substance, and then based on mole to mole ratio and based on the stoichiometric relationship, we can estimate the number of moles of another substance in chemical equation. And then when we found the number of moles for this substance, and if we multiply it by molecular weight, we can get the mass of B. Let's have some examples. For example, here we have glucose plus oxygen is going to give us 6 CO2 plus 6 water. So how many grams of oxygen must the body take in a completely process 1 gram of glucose? So then we need to see how much oxygen we require. So we need to convert this gram of glucose to number of moles, and here we have this relationship. So 1 mole of glucose will react with 6 moles of oxygen. So then we can convert it again from number of moles of oxygen to number of mass of oxygen. So it's going to be basically the same thing. We have grams of substance A. If we divide it by molar mass or molecular weight, we can get the number of moles of A. Then based on formula or based on the balanced chemical equation, we can estimate the number of moles of any other substance, either product or reactant. And then when we find the number of moles of B, we can multiply it by molar mass or molecular weight of B, and then find the grams of substance B. Let's have this example. To prepare 1.5 times 10 power 2 gram of calcium oxide, how many grams of calcium carbonate should be used? Assuming 100% conversion to product. So here we have calcium carbonate, and the products are calcium oxide plus CO2. So we need to produce 1.5 times 10 power 2 grams of calcium oxide. So we need to, first of all, find the molar mass of this guy. We need to divide the mass by to find the number of moles, and based on that we estimate the amount of calcium carbonate. So here is the molar mass of CaO and CaCO3. Here's 100.09 grams, and the other one is 56.08 grams. So 1.5 times 10 power 2 grams CaO, that's the molar mass. We can then find the number of moles of CaO, and we can see here based on this equation 1 moles of calcium carbonate will produce 1 mole of calcium oxide. Okay, and based on that we can find the number of moles of calcium carbonate, and then we multiply it by the molar mass to find the mass of calcium carbonate. So we have 1.5 times 10 power 2 grams of CaO. We have this ratio to find the number of moles of CaO. Then we have 1 to 1 based on this chemical equation. And then we need to multiply it by molar mass of CaCO3. So, and all these units cancel each other. This, and this. So, we have 109 grams CaCO3 at the end. So if we do the calculation, we can say we need to have 268 grams of calcium carbonate to produce this amount of carbon dioxide.